हेलो स्टूडेंट्स, मोस्ट वेलकम इन मैथ वीक अकेडमी। माई सेल्फ अनूप वर्मा। और यहाँ पर हम हायर मैथमेटिक्स को डिस्कस करते हैं, तो आप हमसे जुड़कर हायर मैथमेटिक्स को सीख सकते हैं, समझ सकते हैं। बीएससी, एमएससी एंड सीएसआईआर नेट गेट लेवल का मैथमेटिक्स में यहाँ पर डिस्कस करता हूँ। सो आप यहाँ पर सब्सक्राइब कर लीजिए चैनल को, और यहाँ से आप चीजों को सीख सकते हैं। अभी हम लोग डिफरेंशियल कैलकुलस का पेपर पढ़ रहे थे, जो कि बीएससी फर्स्ट सेमेस्टर में है, लखनऊ यूनिवर्सिटी के सिलेबस में। आप किसी भी यूनिवर्सिटी से हैं, आप इस पेपर को पढ़ सकते हैं अगर आपकी यूनिवर्सिटी में। आई थिंक इन द फर्स्ट ईयर दिस कंटेंट इज डिस्कस इन मैथमेटिक्स in every university. So you can learn from here, and you can complete your syllabus, you can complete your mathematics. Okay. So in the last lecture, we have discussed about limit, continuity, and differentiability. That covers the first unit of the syllabus of Lucknow University. Now I will move for the next lectures, and I will complete all. I have to complete all the syllabus of this paper, and then we move for the next papers. Okay, so let's today discuss about the limits of the indeterminate forms. So first we know what are the indeterminate forms, and then I will just step by step how we calculate the limits of the indeterminate form. And it is very easy to calculate a limit of indeterminate form by using the L'Hospital rule. So what is the L'Hospital rule and how we will apply it? The French mathematician D.L. Hospital is formulated this theorem. How we calculate the limit of indeterminate forms. Okay, so let's start today's lecture. Let me share a screen to you. Okay, so we are going to start the chapter number 2, limits of indeterminate form. Okay, so let's first know what are the indeterminate forms. Okay, so we know that when you are going to calculate the limit of a quotient function like this, if you are going to calculate the limit when extending to a of fx divided by g. Okay, so this is the quotient function. If you are going to calculate the limit of this, so this limit exists if we have the limit extending to a of fx, and you have the limit this extending to a of gx, and this, if this is RHS exists, and this should be provided, this will be exist provided the limit of the denominator of gx is not equal to g. Okay, so this is limit exists, but what will happen when the limit of numerator and denominator is same? If you have you can say the limit of, if we have if we can just say, if limit x tending to a of fx is 0, and this is also the limit of denominator, this g. Okay, then you can see easily this limit of x tending to a of fx upon gx will be equal to 0 upon 0. One thing we know that the divisibility by 0 is not defined. So this 0 upon 0 is a meaningless. This is the meaningless one. This is meaningless. Okay, so if we have somehow, if you are going to calculate limit of a fractional function as the effect upon gf, and you get 0 upon 0 form, so this is the this is called a indeterminate form. So this is called a indeterminate form. This is called a, mathematically we will say this limit is a indeterminate. Okay, so you can just say this is the indeterminate form. This expression is called indeterminate. इसको हम डिटरमाइन नहीं कर सकते। Okay, so in the similar way we have 6 more indeterminate forms. So other indeterminate forms are minute forms, or we have you can say infinity divided by infinity. This is also a meaningless quantity. Okay, if you are subtracting infinity from infinity, what we will get, we don't know. When you multiply 0 with infinity, you know that if you multiply 0 with a finite number, you will get 0. But when if you multiply infinite with 0, you can't say anything, because we have defined and we have know that if you multiply 0 with a finite number, you definitely get a 0. But when you multiply it with the infinite number, you can't say anything. Okay, and also we know that 1 to power infinity, if you are have some finite number here, then 1 for the finite number will becomes 1. But what will be value when 1 for infinity? This is the undefined value. You can say this is the indeterminate. It means we cannot determine this value. Okay. Next, this is infinity to power 0, and this is 0 to power 0. And we know that from here, we know that if there is any number in the place of 0, if you have any number a, which is for 0 is just equal to 1 if a is not equals to 0. So this is the defined quantity. If you have a non-zero number and the exponent is 0, then you will get 1. But if the base is 0, then what will be the value? We don't know. So this is the indeterminate form. This is also indeterminate form. This is also indeterminate form. So they are the 6 and plus 1. There is a 7 indeterminate form. So you can also again, if you are also have this 0, 0, so this 0, 1, 2, 3, 4, 5, 6, and 7. So they are the 7 indeterminate form. Okay. So if we get limit in such a way, in this way, indeterminate form, so then how we will calculate such type of limit? So this is this chapter is based on that, and there's a French mathematician we have developed. They have methodology. He developed a theorem. Then how we calculate the limit of indeterminate form by using the derivative. Okay, so that was the mathematician. Name is uh, name is D.L. Hospital. So you can have this French mathematician was there. Okay, he developed this thing. It was a French mathematician. This is a French mathematician, and this is name is D.L. Hospital. Simply they say L Hospital, and same author, and it's some they are the there's the hospital is there, the hospital rule. There's somehow they read as hospital rule, and in the some author in their textbook they use the spelling is hospital only. So we will use here, we will say this is DL hospital. We will say only L hospital group. Okay, we can say this is L hospital. This is a French mathematician. The duration of their life, you can have this is 1 to 17. Okay, so this is the French mathematician. We developed this thing. Okay, so let us see how we will just get this formula. So L hospital rule we will. So let us start with 0.0 indeterminate form, and then infinity and infinity, then infinity minus infinity, and one by one I will discuss. If you get limit in such a way, then how we will calculate such limits. Okay, so let us see. So first we are going to discuss about the form the form 0 upon 0. Okay, so this is thing I am going to discuss. So if I am taking two functions like if fx, let fx and gx are two functions. Two functions, okay, of x such that वैल्यू एट द ए, मतलब जिस पॉइंट पे हमें लिमिट निकालना है, वैल्यू ऑफ द फंक्शन एफ ए इज जीरो, दैट दिस इज एफ ए is just equal to 0 and GA is this point is also 0, then you will get 0.0 form now. And both are differentiable function because we need a derivative. Both are differentiable in a given interval. Interval that containing the neighborhood of the A point, containing the point this is x is equals to 8. Okay, so if they are differentiable in the interval containing the point A, तो उस interval में differentiable है और A point पे इनकी value 0 है, it means we will get a 0.0 form. Okay, so if we have taking another point, we have a Lagrange mean value theorem. So I will use here the Lagrange mean value theorem. Okay, so if we have if A plus H, if A plus H is another point, and because H is very small, H is tending to 0, H is very small, that is tending to 0, then if a interval which containing A, then this A plus H is also containing in that interval. Okay, so if I'm taking if A plus H is another point contained in this interval, then we use the Lagrange mean value theorem. Interval, we have the form of the Lagrange mean value theorem. From Lagrange's mean value theorem, okay, what we have? We have this is f of A plus H is divided by G of A plus H. Okay, is just equal to fa plus H of f dash of A plus theta H, and this is theta is lies between 0 and 1, right? And this is divided by GA plus H of G dash A plus theta H. Okay, so we can able to get this form if we are taking 2 points A and A pluses from the same interval. Okay, we can able to write like this. Okay, एक चीज तो हमें पता है कि this FA and FB, FA and GA are 0 at the point A. So from here you will get in this way. This implies we get this is f of A plus H divided by this is G of A plus H is just equal to this is 0 plus this is your H, f dash of A plus theta H, and this is divided by this is 0 plus h g dash of a plus theta h. Okay, and you are cancel this h with it. So you will get simply this is your f dash of a plus theta h, and this is divided by this is g dash of a plus theta h. Now you can take limit. Okay, now taking limit. So this implies when you're taking limit, this is limit, this is h tending to 0. We are taking the limit h tending to 0. So this is your f of a plus h divided by this is g of a plus h is just equal to this is limit h tending to 0, and this is your f dash of a plus theta h divided by this is your g dash a plus theta h. Okay. Now when you apply this limit, you can see clearly that this is your RHS limit at this point A. So similarly, you can also for this. So you can also write this is limit A tending to oh sorry x is tending to A, है ना. RHS लिमिट लिखे तो उसको अगर लिमिट के फॉर्म में लिखना हो तो यू कैन इजिली राइट लाइक दिस इज x टेंडिंग टू A ऑफ fx डिवाइडेड बाई दिस इज g, है ना. ये तो होता था, यू नो दैट कि इफ यू आर गोइंग टू फाइंड द राइट हैंड लिमिट RHL तो यहाँ वैसे लिखते थे लिमिट h टेंडिंग टू 0, एंड यहाँ पर हम रिप्लेस करते थे इसको a प्लस h. यहाँ पर फंक्शन क्या है f अपॉन g एज अ फंक्शन. ओके, तो दिस विल बी इक्वल टू, and when you apply h equals to 0 here, so this term when theta h or theta h will be become 0, so you will get from here this is your f dash of a divided by this is g dash of a. So this is the important fact we will get. Okay, so clearly you can say this will be exist, and provided this both f dash a and g dash a not simultaneously equal to 0, and g dash a should be not equal to 0. So this will exist, this will equal to this, provided you can say this is your f dash a is not equal to 0, and this is g dash a should not equal to 0. So this is f dash a upon g dash a. So this limit will be equal to, you will take the derivative of the functions numerator and denominator separately. You take the derivative of the numerator and denominator separately, and then put the value of the x. Okay, you will get the, so this is known as actually L'Hospital. So this is called L'Hospital. HD L'Hospital. Okay. If we can have suppose that if f dash a equal to 0 and g dash a is equal to 0, again we will get 0 0 on the derivative as well. Then you can again apply the L'Hospital rule on the derivatives function. जो derivative होके function बने हैं उनके ऊपर फिर से हम L'Hospital rule लगाएंगे. ठीक है, तो same we can now apply this rule. Till then we get 0.0 form. 0.0 फॉर्म मिल रही है, वी कैन डेफिनेटली अप्लाई देयर L'Hospital रूल. तो 0.0 फॉर्म जब तक मिलती रहेगी तब तक L'Hospital रूल हम अप्लाई करते रहेंगे वन बाई वन तरीके से. तो इफ हाउएवर यू कैन से f dash is just equal to 0 and this g dash is equal of a is just equal to 0, then we apply DL hospital, L hospital rule again. So we get, so again if we apply this again, then again take the derivative, second order derivative, third order, इस तरीके से, and definitely the function should be differentiable in the neighborhood of A के neighborhood या कह सकते हो interval containing A, that should be डिफरेंशिएबल. फंक्शन डिफरेंशिएबल होगा तभी उसके डेरिवेटिव्स आप निकाल पाओगे, देन फिर यू कैन एबल टू अप्लाई. बहुत सिंपल है, बट द मेथोडोलॉजी बिहाइंड दिस फार्मूला वी शुड नो कि कैसे काम करता है और क्या क्या चीजें फीचर्स हमारे पास है इसके अंदर. तो इफ यू आर अगेन डिफरेंशिएटिंग यू कैन गेट दिस लिमिट एक्सटेंडिंग टू a is just equal to this is fx upon gx is just equal to this is limit, and this is your x tending to a, this is your f dash of x divided by g dash of x, and you can have limit when extending to a, f double dash x, and this is upon p double. And a similar way you can follow when till you get the 0.04, and after one stage you can able to find the limit of that what fractional function you can say in the uh, rational function, a quotient function. Okay, so let's learn about the generalized d hospital rule. If you are generalizing this to up to n a derivative, you can able to till you can also able to find the limit of the function. Okay, so if you are generalizing this theorem, generalization of D L hospital rule. Okay, so let's write the define theorem. What is the theorem? Simply, if you are their derivative till n minus 1 and till n, and you are getting the 0.0 you can apply like a successive derivative, first order derivative, second order derivative, third order in sequence. And one thing you remember, we are differentiating separately, numerator and denominator separately, alag alag. Okay, so if fx, right here, if fx and gx, if fx and gx are two functions, each differentiable, n times. Okay, n times differentiable, and if first order derivative, second order derivative at the point A, and up to n minus 1 times derivative the value, and similarly first order of the derivative of g, second order derivative of g, up to n minus 1th order derivative of g, all are zero, or all zero. If all zero, and but the nth derivative is not both zero, then you will get the limit of the function by applying again and again the L hospital rule. Okay, so this is but you can say this is f nth derivative with a, and g and a nth derivative of g are both are both not zero, then this is limit, then limit x tending to a, then limit x tending to a, fx upon gx is just equal to, we are taking the nth derivative and then put the value of a, up to nth derivative, the value of a. Okay, so this is the generalization of the DOL hospital. So we will call only L hospital rule. Simply we can apply the L hospital rule. Okay. So this is all about your 0.0 form. If we get a 0.0 form, indeterminate form, we simply, if functions are differentiable, we simply differentiate the functions and then we will put the values of a. X is equals to a. If we further we get 0.0 form, we again differentiate and we again get 0.04, we again differentiate, provided the function should be differentiable. If function is differential, then we can able to differentiate at the a or this neighborhood of a. Okay, so if fx and g are two functions and each are differentiable n times, and if f a dash and f double dash of a and f n minus 1 a and g dash and g double dash of g n minus 1 a all are zero, all are a zero, then f n a and g n a are both not zero, then the limit of the fx upon gx will be equal to nth derivative of f a and nth derivative of g a. Okay, so this will be the vector. Okay, so hope so you can able to let us do a problem. Simply let us do a problem. एक एग्जाम्पल कर लेते हैं. सिंपल, बहुत इजी है, सिंपल सब प्रॉब्लम है. एग्जाम्पल 1, what they are saying, evaluate this is limit x tending to 1, x की power 5 minus 2x cube minus 4x square plus 9x minus of 4 divided by this is x की power 4 minus का 2x की power cube plus of 2x minus of 1. So if this is a function fx and this is a function gx, okay, and if you are going to put the x is equals to 1 here, so you will have in fx it will be 1 minus ka 2 minus 4 plus ka 9 minus 4 is we will get 0. So this is 4 4 9 9 4 4 8 8 or 2 minus 10 and 9 plus 1 is 10. So this will be 10 minus 10 and that will be equal to 0. So the value of the function f1 is just equal to 0. It means value of the function fx at x is equals to 1 is just equal to 0. What will be g of 1? It will be equal to 1 minus 2 plus 2 minus 1. So from here you can see 1 plus 1 minus 1 and this cancel out, we get 0. So this f1 and g1 both are equal to 0. So it will be, you will get this is a 0.0 form, 0.0 indeterminate form. Indeterminate form. Okay. So how we will do? So by since we have by L hospital rule, so what we have, this limit, you know that limit x tending to a fx upon g. अब जितनी बार भी कोई प्रॉब्लम करें, उस प्रॉब्लम में जो भी फॉर्मूला यूज हो रहा है आप उतनी बार उस फॉर्मूले को लिखे जरूर प्रॉब्लम सॉल्व करते समय। तो जब आप फार्मूला लिखेंगे तो आपको दिमाग में सेट हो जाएगा फार्मूला। दिस इज इक्वल्स टू सिंपली एफ डैश ए डिवाइडेड बाई जी डैश। ओके, सो दिस थिंग यू नोट, यू वांट। तो यहाँ पर हमें पास a बराबर है 1, and what will be the derivative? So now we are going to this now we are going to calculate this limit x tending to 1, and this is x power 5 minus the 2x cube minus the 4x square plus the 9x minus the 4 divided by x power 4 minus the 2x cube plus the 2x minus the 1. When you are taking the derivative, तो डेरिवेटिव विल हैव टू सेपरेटली न्यूमरेटर एंड डिन्यूमरेटर। तो यहाँ पर हमारे पास जो लिमिट हो जाएगा, लिमिट एक्स टेंडिंग टू 1, so what will be the derivative? This will be 5x की power 4, and this 3 to the 6 minus 6x square, and this is minus of 8x and plus of 9, and this is divided by 4x cube. We are taking derivative, and this is the 6 minus 6x square and plus of 2. So now if you again put, if you are uh, again put x equals to 1, so it will be 5 minus 6 is minus 1, and minus 1 and minus 8, it will be equal to minus 9 and plus 9, so you will get 0 in numerator. And when you here you put x equals to 1, this is 4 minus 6 plus 2, this is 6 minus 6 is equals to 0. So this is again 0 for 0 form. So again apply L'Hospital rule again. Again apply L'Hospital rule. So that will be equal to what? This equals to limit equal to limit x tending to 1. Again हम differentiate करेंगे इसको. So it will be 4 5 is 20 of x cube, and this is minus of 12 of x and minus of 8 divided by this is 12 x square and minus of 12x. Okay, so you again, if you are put again here, you x equals to 1, so this will be 20 minus 12 minus 8, so minus 12 minus 8 will be equal to 20, the 20 minus 20 is equals to 0, or this is 12 minus 2, this is again 0 upon 0 form. Again you apply your L'Hospital rule till you get a non-zero number, or you can say not 0 upon 0 form, you will have to apply this L'Hospital rule. So again apply. So this is x tending to 1, and there will be 23 just 60 x square and minus of 12 divided by this will be 24 of x minus 12. Okay, now I think you will get a non-zero number. So again we applied the L'Hospital rule. So if you are just put x equals to 1, this is 60 minus 12, this is 24 minus 12. So now we will get a non-zero number. So this will be 1, this is 60 into 1 square minus the 12 divided by 24 into 1 minus the 12. Sorry. Then 24 into 1. So 60 minus 12 is what? 60 minus what? It will be 60 minus 12 is remaining, and this will be equal to 24 minus 12. So here 60 minus 12 is 48 divided by 12. Okay, so this is 60 minus 12 is 48 divided by 12. So 12 4 ja 48 upon 12. So this is your answer of this limit. So here we have 2 and 3 times 0.0 form. So you just apply again the L hospital rule, and you will get the answer in the last. So answer will be equal to 4. ओके, तो आई होप सो कि आपको कॉन्सेप्ट कि कैसे हमारे पास हॉस्पिटल रूल काम करता है, उसमें डेरिवेटिव्स का यूज होता है. इट इज नेसेसरी द फंक्शन शुड बी अ डिफरेंशिएबल फंक्शन बिकॉज वी नीड अ डेरिवेटिव. तो एफ एक्स एंड जी एक्स both should be differentiable. If one of them is not differentiable at any point inside the domain or in the domain, then it will can't able to uh, say about these type of things. Okay, so we will meet in the next lecture with the next thing about. In the next lecture, we will discuss about the how we calculate the limit of a function that function is infinity minus infinity form. That gives the infinity minus infinity form. Okay, so thank you so much for watching and learning mathematics from here. And for the updates, kindly subscribe the channel and hit the bell icon. Thank you so much.